We took a look at Wireshark previously, but we didn't dig that much into capture filters and display filters. We talked about them a bit, but today we're going to really dig in more. Using these capture filters and display filters, you can actually find useful information rather than just seeing a mountain of data, throw it in your face while capturing traffic. So I'm going to bring up Wireshark here. Wireshark's in the top right. I've got my web browser open, and then of course our lab guide. So I've found my active interface. We can see that's because the spark line's here. It's the most active graph. It's my local area connection. So I'm on a wired connection right now. So I'm going to highlight this, and I'm going to enter a capture filter. Now there's a specific syntax for this capture filter, and a key idea is that the capture filters are different than the display filters. Why the people who created Wireshark did this, I don't know. It doesn't make a lot of sense to me. It's just the way it is. I'm going to do port 53. Okay, so do you know what uses port 53? That would be DNS, domain name. So when we're looking up domain name and we want to know the IP address, we're going to use DNS, which works over port 53. That's the standard. So if I start this, I'm not going to see any traffic unless it's a DNS lookup. So I'm going to come here to www.yahoo.com. So we've got the yahoo.com webpage. I actually don't care about any of the content on the web page. I care about the network traffic. So we can see here there's a bunch of DNS lookups. I'm still capturing data. I'm going to click stop because I don't really care about capturing any of this stuff. I'm going to close that tab just because I really don't want to read about Bill Cosby. And here we are. We have a whole bunch of DNS lookups. So we went to a single web page, but we look at how many DNS queries we ran. So there's a bunch of queries, and then there's responses. So you can see the first packet. The source, that's going to be my IP address. The destination is my DNS server that I'm using to resolve these entries. I did a query, standard query for yahoo.com. So let's dig into this a little bit. I'm going to expand Wireshark. Let's look at how big this DNS query is. Pretty basic. There's not that much data being sent. It's just saying, hey, what's yahoo.com? Type A. So A is just a regular IP version 4 address. Simple enough. What do we get back? We get back a bunch of information. You can see here, it's giving me an IP address for Google. It's giving me authoritative name servers for Yahoo. Additional information that my web browser might need to find the correct IP address for yahoo.com. Okay, that's great. So why do we have all these other requests in here? Well, on yahoo.com, that web page links to a bunch of other resources on other domains besides www.yahoo.com. So let's find a friendlier one. s.yimg.com. I'm going to assume that that's Yahoo Images. They have a custom domain just to serve up all the graphics on their webpage. There's resources from search.yahoo.com. It could be a picture like the search. The icon for the search button might be served from that domain. There's analytics happening. And then of course, we're going to come down, if we come down even farther, there's a whole bunch of stuff, right? Eventually, we'll start to get to ads and things. And I don't mean to make you sick scrolling. Okay, we have a different domain, akamaiedge.net. So Akamai is a content distribution network. For companies that don't want to scale up or scale down their whole infrastructure, they can outsource their content hosting to Akamai. And so that's why we're seeing some Akamai stuff here. This could be, again, images hosted by Akamai, could be content, could be a lot of different things, could be advertisements. Also Google.com, which is interesting. I'm not sure why Yahoo.com is linking to something Google. I'd have to dig in a little bit more. But if we keep going down, okay, we see some tracking. So we've got scorecardresearch.com. So people are trying to track my browsing behavior. So if I go to yahoo.com, then I go to cnn.com, for example, Scorecard Research, if it has a 1 pixel image on either web page, it can track me across those browsing those 2 different websites, even though they're on different domains. So there's tons of DNS lookups happening here. There's other tracking. There's a lot of tracking. Ads and tracking is probably the bulk of the DNS lookups on here. At least half. It's a lot for Yahoo.com. It's the way these modern companies make money. So I can dig into DNS and I can see what's happening. I can see all the domains that are being loaded on this web page by capturing the packets. Notice that I don't have any display filter, so I'm showing 100% of the packets that Wireshark captured in this instance. Excuse me. So display filters are going to be a little bit different. Display filters, let me pause real quick. So display filters just filter out the packets that I've already captured, looking for specific information. So if I wanted to filter DNS packets, I could choose udp.port equals 53. That would be the same filter basically as before. And I'm going to click this arrow to apply. And so now this filter is applied. And how many packets did I filter out? Well, I filtered out 0. I can see there are 230 captured packets, and I have 230 displayed right now. So nothing was actually filtered, so that's good. I just wanted to show you the different syntax here for applying a display filter that would do the same thing as the capture filter port 53. So DNS uses UDP instead of TCP at the transport layer. So that's why we did UDP and not TCP here. So I'm going to clear this expression to clear my filter. And again, I've got 230 displayed. Let's do this. I'm going to continue without saving. I'm going to clear my capture filter. And I'm going to start capturing traffic. So I've got Dropbox running on my machine, so I can see Dropbox, the LAN discovery protocol, whatever. Tons of data. So I can see so far, just in the couple of seconds that I've been capturing data, I've got about 1,000 packets captured. It's a lot. So I'm going to come to a new website. I'm going to come to cnn.com just to add some more network traffic. And I'm just going to stop my capture. So loading CNN.com, my packets went up by about 10,000. 100% displayed. I've got no display filter here. All right, I'm going to close CNN because it's probably just loading ads and stuff in the background. All right, this is good. I'm going to do the display filter udp.port equals 53. All right, and how many packets do I have here? About 1,000. Holy moly. So CNN is a lot worse than Yahoo as far as DNS queries. That is impressive what CNN.com is doing. Tons of tracking cookies, tons of advertisements. That is kind of scary, to be honest. Yeah, usertrust.com. As a user, I do not trust CNN's website, just based off of all the DNS queries that are happening. So I could analyze DNS for CNN. Now, I'm going to, let's see what other filters I can do. So I'm going to go to the wireshark.org webpage. There are capture filters and there's display filters. Let's see. Actually, I want to go to the display filters right now. So it's going to teach me about different display filters that I can do. So I could look for tcp.port equaling 25. I can apply that. Okay, I see no traffic. So why might I see no traffic? What is port 25 used for? Well, it's for sending email. I didn't send any email when I loaded CNN.com, so I'm not going to see any of that traffic. So I'm going to clear that. There shouldn't be any ICMP traffic. Nope, I didn't ping anything, so there shouldn't be any ICMP. I could filter by IP address source or destination. This would be useful if you're capturing packets in promiscuous mode, where you're capturing tons of people's information. There's a lot of... I could filter based off of HTTP request, looking for the URL. If I'm looking for a specific bit of text or a string in that URL, I could run that query. I'll paste that filter in. We probably won't get anything. What could I find here? If I look for JPEG, I'll find in the web pages JPEGs. So if I was looking for something like a social security number, I don't know, SSN, hypothetically, you know, if you're capturing a lot of data and you're looking for sensitive information, you could try to create a filter that would find those social security numbers for you, or passwords, things like that. So the good thing about a display filter is that I've got all this data captured, and then I can kind of dig in post hoc and go through whatever I need to. So I'm going to, there are more in the submission in section 24.4. There's some exercises to try doing additional display filters and capture filters. So let's just go through that. I'm going to close this, continue without saving. So it tells me my capture filter should be port 53, port 53. And so I'll start capturing, and it tells me go to http www.nmu.edu. So I can see the DNS lookups that happen here. Quite a bit still. Northern Michigan University does track us. There is some tracking code in here, some content distribution. It's actually quite a bit. You know, that's okay. It's all for good purposes, right? I know the marketing department at Northern does quite a bit to track who's visiting the webpage, and they do a lot of analytics. So I could take a screenshot of that right now. That's good. So I'm going to stop capturing. I am going to close this. And my capture filter, I'm going to choose host, www.nmu.edu. And I'll start capturing this data. So I'm going to reload the web browser. So I only see information about nmu.edu. So I've got 195 packets captured here, a few more trickling in. If I go to, let's say, msnbc.com, I'm not capturing any more data in Wireshark because it doesn't match nmu.edu. Okay. So that's good to see. Let's start a new capture. So I have to stop, and then I'll close this. Make sure to take screenshots as you're going through this exercise yourself. IP, so Internet Protocol, and host www.nmu.edu. So that's going to fine-tune my filter. So now what happens if I come to nmu.edu? I'm going to filter out some of the packets that don't use Internet Protocol, just like local broadcasts, those types of things. We've got our TCP handshake there. It's good to see. We see the GET request to get the home page. Fun stuff. I've got DNS. All my DNS should be cached now, so I shouldn't have to do any more DNS lookups. This is good. Then it's closing off my connection there. Alright, so I'm going to stop that. I'm going to close this, continue without saving. Again, make sure you're taking screenshots. We have to go back and do it all over again. Alright, so I'm getting ARP requests already. This is pretty fast. Sometimes you have to wait, 1 or 2 minutes before you see an ARP request on the network. So this is happening. This is being broadcast on my local area network. I'm seeing ARP requests for devices connected to the same switch that I'm connected to. So all these computers can communicate. This is good. I can stop this. I can dig into ARP. So this is a who has sender MAC address, sender IP address, and it shows who it's trying to go to, but it doesn't know their MAC address. That's why it's all zeros. So that's good. I am going to close this, continue without saving. So no capture filter, so I'm going to delete that capture filter. And I'm going to reload nmu.edu. And it looks like it's finished loading. So I'm just going to go ahead and stop the capture because packets are going to keep rolling in basically forever. And let's look at tcp.port equals 80. So this is web pages. That's what uses port 80. We have some 304 not modified because I've already loaded this web page. NMU servers responded and said, hey, the same thing you tried to load 1 minute ago, it hasn't changed, so just use the one you used to have. Let's follow this TCP stream, just for giggles. We see the GET request, we see the response. Yeah, we see a lot of the responses here are not modified. Nothing has changed. Follow TCP stream. Close that. If you want to follow a different TCP stream, close it. I was just following the same one. I'm going to apply my filter again. tcp.port equals 80. That's the very first one. Looks like it's maybe finishing off an old one back there. Follow TCP stream. This is interesting. Looks like this is all encrypted. Just a bunch of garbage. Must be secure. So that's good to know. So I'm going to do another capture. No filter. And I'm going to go to, I've already gone to CNN.com. Let's go to it again. And I'm going to stop the capture. And this will be interesting. What do we see? UDP.port equals 53. So I still see a good number of DNS lookups here. A whole lot of DNS lookups. 912 packets displayed, so 20% of the traffic, as far as number of packets is concerned, is DNS. Here's one thing to look at. The query, how big is it? 86 bytes. The response is 468 bytes. So a fairly small request ends up with a fairly big response. This is one reason why people performing denial of service attacks use DNS, because machines can do a DNS request and spoof who should get that response, and that response is much bigger. It's called amplification. All right, so the last thing we're going to do, one more, we'll close this. So my capture filter, not ARP and not STP. So STP is spanning tree protocol. We don't care about that layer 2 stuff right now. So I'll start capturing. I'm going to go to just reload CNN.com. Fine, I'll do it. Did it reload? I can't tell. There's so many ads and pop-ups on CNN.com, I'm not sure what's happening. I think I got it though. So I'm going to stop. I'll clear this filter. And now we can do tcp.port equals 443. So that's encrypted web traffic, or tcp.port equals 80. So that those two vertical bars, that means or. I think that's Java syntax. It's been a while since I've done Java. TCP port is 443, or TCP port equals 80. So that'll give me encrypted or unencrypted web traffic. I'll apply that filter. So that's good. I'm getting a bunch of stuff. I can sort by protocol, so I can just take a look. There's a lot of HTTP traffic here. We have TLS. This is basically just encrypted traffic, transport layer security. So this is the stuff happening over port 443. Yeah, if I look at the transmission control protocol, it tells me the source port is 443. Yeah, that's good. So play around with Wireshark. So find one more capture filter that you think is interesting, find one more display filter, take screenshots, put all that stuff into a Word document, and you'll be good to go. So learning how to use Wireshark is a good skill. Using these filters and being able to dig into the details for each packet, it's something that you want to be familiar with if you want to have a successful career doing anything with cybersecurity or networking.